Welcome to another session for optimization techniques. In this session, we are going to our discussion about CLO number 1, which is related to DOE or different type of design of experiments. In this session, we will discuss about the factorial design of experiments, which is one of the most famous and common type of the design of experiments. However, today I will try to give you all of the details for this topic, but you need to also refer to our textbook under study page 179 to page 190 to get more information about this type of the design of experiment. First, let me just review what you have learned up to now, then we can go to the detail of this design of experiment. First of all, why we need to have a design of experiment. If you remember, I told you that we need to have a design of experiment to design an analysis of experiment which shows or which can help us to understand effect of different variables on other variables. These variables, as it is mentioned here, some of them we are going to see the effect of some of them on the other variables. Based on this classification, we can say that we will have a cause and effect relationship between two class or categories of the variables which are called independent and dependent variables. Dependent variables are which also called responses, are the variables which we measure. They are not under our control, and we just understand, we are just interested to know how they change. On the other hand, we have independent variables or factors which we are interested to see their effects on responses or dependent variables. So this is important, actually very important. From now on, we have dependent variables or responses, and also we will have independent variables or factors. And for the factors, which as I mentioned earlier, are the variables which are under our control, and we can set different values for these factors. Similarly, for example, the temperature, when we control it, imagine we are going to study the effect of the temperature on the comfort level of a person inside the room. Then temperature is a factor, comfort level is a response. Later we will see an example related to this. And these different temperatures which we are going to check, for example, or different values of the factors are called levels. So for each factor we may have different levels. Here we have few examples of the independent and dependent variables or responses and factors. As you know, and as we discussed earlier, for any study or any research, we need to have a robust research question. So first, the first example, the research question for first example is, what is the effect of diet and regular soda on blood sugar level? As you can see here, we are going to study effect of some variables on other variables. Blood sugar is one variable. We are going to see how it will change. So we measure it actually. On the other hand, we have the diet and regular soda types, and this type of the soda is the factor or independent variable. As you can see here, the type of soda which we drink, diet or regular, is the independent variable or factor, and the blood sugar level actually is the dependent variable. We measure this but we control this. We can change we can decide which type of the soda we are going to drink. But blood sugar, we just measure. So it is dependent variable. The other example is, how does phone use before bedtime affect the sleep? So another example we have here, the value or the amount of the phone which we use before bed is our independent or our factor, because it is under our control. We decide how long we use our phone before we go to bed. So this is a factor because we control it. But number of hours to sleep, which is something we just can observe, we can just measure, is our independent variable or response. Or quality of sleep, this one also is something we just observe. We cannot control it, or we are not interested to control it, and we are just going to see effect of amount of the phone used before bed on the quality of the sleep. This one is the result of the measurement, observation, and so on. So these two examples hopefully can help you to understand the difference between the independent and dependent variables and also their levels. So you have seen two examples, and you have seen what are the dependent and independent variables. Now let's see about the factorial design. First of all, why we call that factorial design, we have already discussed, because we are going to study different factors with different level and see the effect of some factors on some responses. Many experiments which we have are including two or more factors, which or independent variables. For these kind of the studies or experiments, the most appropriate type of design of experiment is factorial design of experiment, and it is most efficient for this type of experimentation. Why? Because in each complete trial or replicate of the experiment, I hope you already know about replicate from previous sessions, all possible combination of the levels of the factors are investigated. So we will have different levels for different factors, and finally we will check the main effect of these different factors, and also we can check the interaction effect of these two factors or three factors and so on the responses. So by this we can check actually all avenues or all effects of the factors on the responses. So we have an example here, which is about the comfort level inside a room with different temperature and humidity. So our design of experiment here included two factors. One of them is humidity, the other one is temperature. So we have two factors. Factor A is temperature, factor B is the relative humidity or simply humidity percentage. So we have factor A and B, and we have to check the effect of these two factors on the response, which is the comfort level. We need to have different level for our factors. So we choose two different levels for these two factors. For factor A or temperature, we check temperature 10 degrees Celsius and 25 degrees Celsius. So factor A has two levels, 10 and 25 degrees Celsius. Factor B or humidity also has two levels, 10% and 50%. So we have two factors with two levels. Each one has two levels. Now, as I told you before, we need to have response. Our response is level of comfort, but we need to make this comfort level quantitative to be able to measure that. So we can ask our individual, which is inside the room, to give a score to the comfort level from 0 to 10 for maximum comfortability at 10 and least comfortability at 0. So now we are going to run our experiment. How we do that? We set temperature inside the room at 10 degrees Celsius and its relative humidity at 10%. Then we will ask the individual what is the level of the comfort for you inside this room with this condition: 10 degrees Celsius, 10% humidity. And as you can see here, the answer has been 0. This is the result of the experiment. So it is 0, least and no comfort level at all in this temperature, very low temperature and very low humidity. Now we keep this constant, the temperature, and we increase the relative humidity to 50%. This time, as you can see here, the comfort level has increased. Again, the individual has filled the form. The score this time is 2. A still low comfort level, but higher than the first condition. And after that, we change the temperature to 5 degrees Celsius to 25 degrees Celsius and keep the relative humidity at 10%. As you can see, the comfort level has increased to 5, but it is moderately comfortable, but not very comfortable. Then if in the last point or sample which we are going to test is 25 degrees Celsius and 50 degrees Celsius, we run the experiment. We set these two temperatures and relative humidity inside the room is to 25 degrees Celsius, 50% humidity, and we check the comfort level. As you can see here, answer is 9. Very comfortable level in this condition. Temperature 25, relative humidity 50%. So we have already run the experiments and we have the results. Now we are going to see what are the effects of these temperatures, humidity, and their interaction on the comfort level. As you can see here, simply you can guess by increasing the temperature, the comfort level has increased. By increasing the relative humidity, temperature is increased. But how we reach this point? Okay, we will see. First, let's see what is the effect of A, or temperature, on the comfort level generally. What we can do is to find the main effect or the average value of the effect of this temperature. So 5 plus 9 divided by 2. Two values which we have, we need to find its average, divided by 2 minus the average value at the other temperature, the minimum temperature. 2 plus 0 divided by 2, which the result is 6 actually. The main effect of A is 6. Main effect of B with similar procedure, we can calculate that the average at this the average value of the comfort level at this relative humidity minus the average value of the comfort level at this humidity will give us the main effect of B, or relative humidity, which is 3. So as you can see here, the effect of the temperature has been higher than the effect of the relative humidity. So by increasing of the temperature, as you can see here also, the amount of the comfort level has increased more than when we change the relative humidity. So these two values show these results. Moreover, we may be interested to understand what is the effect of these two parameters together, how the comfort level will change when we change this temperature and relative humidity together. Okay, As you can see here, if one of them is fixed, we change one of the factors, the other one constant, then the result is clear almost. But let's see if we how we can have interaction effect. To do that, let's see in different levels of one factor how will be the comfort level for changing of the other factor. At low level of B, or relative humidity 10%, effect of A can be calculated like this: 5 minus 0, which is 5. At a high level of B, how is effect of the temperature? 9 minus 2, which is 7. So at low and high level of B, we have seen the effect of the A, or temperature. Now, how we can actually explain this? We can say if we change the level of B, or relative humidity, from 10% to 50%, effect of A changes like this: A, B, or we call it interaction effect. Okay, both of them. This is the explanation of this A, B. Okay, interaction effect of A and B. In other words, if we change the level of B from 10 to 50%, then effect of A, how will be? It will be like this: 7 minus 5, high and low, the average value of the uh, comfort level for different temperature at different level of the relative humidity. So simply the average value of these will be 1. So this is interaction effect of these two factors which we have. Simply, if we do the same for the other one, if we say at low level of A, this time we keep constant the temperature A, and we change the relative humidity. Effect of B will be 2 minus 0 equals to 2. At high level of A, effect of B, 9 minus 5 will be 4. Again, if we can calculate interaction effect of A and B, the result will be same. So by this you can check if you have calculated interaction effect correctly or not. So by both of these two procedures, we can find the interaction effect of these two factors. Another way to see how these two factors change, we can show also these uh, results on a graph like this: responsive, which is comfort level from 0 to 10 we have at different temperatures, and these are temperatures, if you remember, 10 and 25 degrees Celsius. And for sure we will have two lines for high and low temperatures of low relative humidity. As you can see here, we can have such a graph. In other words, if we have two lines parallel to each other, if we draw this graph, if we have two parallel lines, then we don't have any interaction effect. But if they cross each other, like what you can see here, then we can say that we have interaction effect here for our factors, and we need to check that as well. Here are just the basics. To explain, to discuss about the result, we need to have more info, or you need to have the knowledge about the nature of your study as well. After we develop this, after we have checked the effect, main effect, and interaction, we can also develop regression equation from the effect estimates. Again, if you remember our example, now we are going to have equation like this. Imagine, this is general equation. Y here is, for example, comfort level. X is our factors. X1 is first factor, X2 is second factor. No, it depends on the number of factors. And this X1 2 means the interaction effect actually. So we can have this equation which shows the relationship between comfort level and temperature and humidity and their interaction. So this is also important. To find that, we need to find these constants. Okay, beta 1, beta 2, beta 1, 2, and also beta 0, which is a constant value in our regression equation. If you want to know more about regression actually is a line which we can draw in our space to show the relationship between the comfort level and different factors, which is closest to each point. But simply, this is our regression equation. This is regression equation. For example, this one, comfort level. This one, x1 is A, for example. X2 is B in our example, and this is A. How we can find B0, B1, B2, and B12? We need to calculate like this. Effect of A, which we have, if you remember, it was 6. We have calculated main effect. It was 6. To find B, this is general equation, B, capital B. If we want to have the average value, this is average comfort, then we need to find the average. Average value of this, we need to divide by 2 because we have two factors. 6 divided by 2, 3, B2, 3 divided, if you remember, main effect of B was 3, and interaction effect was 1. If you remember, we have calculated already. So B12 is 1 divided by 2. How about B0? B is the average value of all of our data or comfort level. If you remember, we have 0, 2, 9, 5. So simply their average need to divide it by 4. We have 4 different values. So the average value is 4. So B0 will be 4. This is our equation. Why? This is average comfort level, which is equal to 4 plus 3 x1 plus 1.5 x2 plus 0.5 x12. Okay, this is our equation. Then if you have x1 and x2, okay, and when x12, you can find the comfort level for these different temperature or relative humidities. By this regression actually we can plot, have a plot like this. For example, this is comfort level, imagine, and these are the variables, like this one, x1, this one, x2. Then comfort level, will change like this. It will be some graphs, okay? This is, for example, the equation for this graph. Then if you have x1, if you have x2, for example, here, you can find comfort level for that x1 and x2. This is the line in 3 dimensions. If we can draw a surface for this, okay, like this, imagine we have a surface like these different lines. Then we will have a surface. In this surface, on this surface, we can find comfort level for each temperature and each humidity level, A, B, for example. So here, if you notice, we have only 10 and 25. How about 15? Okay, in that case, we can find on this surface, which is topic for response surface methodology, very important, and we will discuss about that in CLO2. Very handy, and it is useful to find too many information about our results, which we will discuss about that later. So by this, you have seen an example related to the factorial design. We had 2 factors with 2 levels. To see more example, please go to the textbook, see this example. This table is the detail of the calculation. We will discuss more about the ANOVA table next session, but you may study about that. And also please a study in this example 5.1, page 189, which is about two factorial design, and you will learn more about how you can have two factorial with two level or two factor factorial design. By this, we reach end of this session. Do not forget to study this example in your textbook and also to practice more example in our textbook related to the two-factor factorial design. Next session, we will mainly discuss about the ANOVA or analysis of variance table. Thank you so much and see you next session.